right? Now we are going to look on some of examples to sketch or to interpret a quadratic function, right? Let's look at this function here. F at x is equal to x squared minus 4x minus 5, right? Let's say you are being asked to sketch this function. You are being asked to sketch this function. We need the following points to sketch a function. The first point will be our y-intercept. The y-intercept. The second point is the x-intercept. The third point, turning point. Turning point or the stationary point. Stationary point. Right. These are the points that we need in order for us to sketch a quadratic function. Right. For y-intercept, we let x to be 0. For x-intercept, we let y to be 0. For stationary point, we use, for x value at the stationary point, we use this equation. X is equal to minus b over 2a. We call this equation the x-axis of symmetry. The x-axis of symmetry. It divides the quadratic function into 2 equal halves. This line here, x equals minus b over 2a. It divides a quadratic function into 2 equal halves. So this is the x value at the turning point. So the x-axis of symmetry, this is x is equal to negative b over 2a. The x-axis of symmetry divide this graph into 2 equal halves. So when we talk of the axis of symmetry is this line. And then now we are saying x-axis of symmetry, that's the x value at the turning point. Axis of symmetry is any line that will divide the graph into 2 equal halves. We call it the axis of symmetry, right? And then if you are to find then, because we are talking about the stationary point, it must have 2 values. It's the value of x and the value of y. So this is the value of x. After finding the value of x, you take this x value into the original to find the y value at the turning point. Let's see how to do all this. Right, the given equation here, it's f at x equals x squared minus 4x minus 5, right? We are to first find the y-intercept. For y-intercept, we let x to be 0. In other words, we are to find f at 0. This will be 0 squared minus 4 times 0 minus 5. Therefore, f at 0 will be equal to, this is 0, 4 times 0 is 0, we are left with negative 5. In other words, our y-intercept will be given by 0 is to negative 5. That's our y-intercept. X is 0. That's our y-intercept. And then for x-intercept, we let y, our y is given by f at x, we let y to be 0. Right? And then use that equation. It's x squared minus 4x minus 5. This is equal to 0. And then from here you can now factorize. It's x, the factors here, minus 5 into x plus 1. That's equal to 0. Therefore, x will be equal to negative 1 or x is equal to 5. These are the roots, therefore the x-intercept will be negative 1 is to 0. And the other point will be 5 is to y is 0. These are our x-intercept, which means our graph will cut x where it's negative 1 and where x is 5. And then we've got the two now, y-intercept, x-intercept. Now we are to find the turning point or stationary point. Remember, for the x value at the turning point, we use this equation for the x-axis of symmetry, which is given by minus b over 2a. It's minus n2. Use the same equation. It's ax squared plus bx plus c. Ax squared plus bx plus c. Therefore, we look for the value of b here. The value of b is given by negative 4. Therefore, it's negative 4. You take this value of b with its sign. Substitute it in the place of b. It's negative, and then in the place of b, you put that over 2 times. The value of a here, the value of a is positive 1. Right. Negative times negative, it's positive. Therefore, we are going to have 4 divided by 2, which is 2. This is the x value at the turning point. So for y value at the turning point, for y value, always if you need y, you go back to original. This is our original equation. So for y value, we use the x value. Substitute the x value into the original equation. Therefore, we are to find the value of y if x is equal to 2. If x is equal to 2. It's minus 4, x is equal to 2, minus 5. Right, we are going to have 4 minus this and that, it's 8 minus 5. And the answer is negative 9. Therefore, the turning point, our turning point will be given by 2 is to negative 9. It's 2 is to negative 9. 2 is to negative 9. That's our turning point. Remember that you can be able to find the x value at the turning point through this. We are being given this equation. It's f of x equals x squared minus 4x minus 5. So, in order to find the x value at the turning point, we derive. So if you derive, it's 2 times 1 there, that will be 2x, minus 1 times negative 4, that's that. And then remember that this is the gradient of a tangent at a stationary point. The gradient of a tangent at a stationary point or at a turning point is 0. Therefore, we'll let our gradient to be 0 because this is a stationary point. 2x minus 4 is equal to 0. Therefore, 2x will be equal to 4, we divide by 2, and then our x will be equal to 2. And then, when you look, we've got same value of x. This x will give us the same value of y. If you are to substitute x into the original, we are going to get negative 9. Right, we've got all our points, x-intercept, y-intercept, and the stationary point. Now we are to sketch our graph. Let's sketch the graph. Right, there is no scale. to sketch a graph, you are just going to use the Cartesian plane only. We need the Cartesian plane to sketch the graph. It's x-axis and the y-axis, right? Let's indicate all these points. Let's start with the y-intercept. Firstly, let's check the shape of our function. The value of a is positive. If the value of a is positive, remember, our graph will be looking like this only if a is positive. If a is negative, our graph will be concave down. So, looking at the value of a here, that means our graph will be looking like that. It will be concave up simply because the value of a is positive. Right. And then let's check our y-intercept. Our y-intercept is -5, which means that will be on the fourth quadrant. Again, our turning point, 2 is to -4. 2 is to -4. That's the fourth quadrant again. And then let's look for our x-intercept, -1 and 5. Right, let's indicate our points. Let's say we've got -1 here. And then let's say we've got 5 there. Right. So 1, 2, 3, 4 up to 5. And then it's -1 like that. Right. Right, we need to have -5 as our y-intercept. Right, and then our turning point. Right, that's our y-intercept. X-intercept, it's -1 is to 0, and then we've got that one too. Our stationary point, 2 is to -9, 2 is to -9. Two is to -9. Let us drop -9. Right, and then our y-intercept there. Let's join our points. Do not join the points using a ruler like this. You can't join the points like that. So you need to sketch a graph as a curve. Up to that point, and then right, and then we go up like that. Right, this is the function of f. Coordinates of this point, 5 is to 0, and then for this point, it's -1 is to 0. Y-intercept, 0 is to -5. And then our stationary point, it will be 2 is to -9. So that's how our function will be looking like. And then for the next question. As you can see, our graph is concave up, simply because the value of A is positive. The value of A is positive. So we have our equation as f at x equals x squared minus 4x minus 5. Right, for the next question.
What is the largest value of C?
We are to find
The largest value of C. For which x squared minus 4x minus 5 is greater or equal to 0 for every value of x. For every value of x.
right, that's our next question. Right. That's our given equation, remember? What is the largest value of C for which x squared minus 4x minus 5 is greater or equal to C for every value of x? Right. Now we have x squared minus 4x minus 5 greater or equal to C. So we are to find the largest value of C for which this is greater or equal to C. Right? This means that when you look here, C is in the place of y. So we are to find this where it is greater or equal to y. In other words, we are to check for where this graph will be existing. It will exist only if it is greater or equal to y. This graph can exist only if there is y there. We can say it is existing. Right? If you are to look here, let's say you've got a turning point there, which is 2:3, like that. Okay, fine. We've got -3 there. So if you are to go down, let's say you are going to have -4, -5, -6, and so on. Right. So at this point, at the turning point, our y is equal to -3. But once you just go down, if you are to move just below this point where y is, remember that our y here is equal to -3. But once you go below this, in other words, y less than -3, below this point, our graph won't be existing. It only exists at -3 or upward. Below this point, if you go down, it is no longer existing. We no longer have our graph. Our graph is represented by C on that case. So, in other words, since we are to find the value of y here, where this graph is existing, you go to your turning point. Below the turning point, a quadratic function doesn't exist here. Since it is concave up, it is no longer existing. Just below this point, it is not existing. For it to exist, it has to be at the turning point or above. It will be always existing for any value of x. It will be existing. But below, it's not there. It's not there. Our quadratic is not there. Right, let's go to our question. Let's go to our question. Remember, for this to exist, we check our turning point. If it's concave up, our graph will exist from the turning point upward. Once you go down, it's not there. It's not there. Our graph is no longer there. It only exists from the turning point upward. If it's concave down, our graph is existing from the turning point downward. This is our graph, from the turning point downward. Once we are above the turning point, there is no graph there. Our graph is not there. It is only from the turning point downward. Once you go up, it is not existing. In other words, for your graph to exist, it has to be equal to that value at the turning point or below. Here, concave up, it has to be at that value at the turning point or above. Right. What is the largest value of c for which x squared minus 4x minus 5, which is our graph, is greater or equal to c, which is our y? Right. There is our graph. There is our graph. So, this graph is existing from the turning point upward. What is the value of y at the turning point? The value of y is equal to negative 9. So for it to exist, it has to be here or above. Below this point, it won't exist. So we are looking for where this is greater or equal to y. Therefore, it's when our c, which represents y, it's where our y is equal to negative 9 or above. It's where our c is greater or equal to negative 9. Right? Remember, in grade 11, to answer this question on the other way around, there is what we call the nature of the roots in grade 11. Nature of the roots. Right, let's see. In grade 11, in the topic that we call it nature of the roots, let's say you have 4x minus 5 greater or equal to 0. It's c here, not 0. It's c, let's transpose that. It's x squared minus 4x minus 5 minus c greater or equal to 0. So remember that we are to find the roots where this is greater or equal to 0. So we use the discriminant for the nature of the roots. It's b squared minus 4ac greater or equal to 0. Right, let's substitute here. Our b is negative 4 minus 4, our a is 1. Right, this is our c. Our c, ax squared plus bx plus c. Our c is given by that. It's minus 5 minus c greater or equal to 0. This will be 16, negative times negative, it's positive. 4 times 5, it's 20. Negative 4 times negative c, that would be plus for c greater or equal to 0. And then we add here 16 plus 20. That is 36 plus 4c greater or equal to 0. Let's transpose. It's 4c greater or equal to negative 36. And then we divide by 4. So we are dividing by a positive number, so the inequality sign won't be affected. C must be greater or equal to negative 9. So you can answer this question either on that form. It's where C is greater or equal to negative 9. That's how to answer that question. It's either you go to your turning point and then you pick that value. Right, let's move to the next question.
Use the graph to solve for x if x squared minus 4x minus 5 is greater or equal to 0.
Right, now we are to find the values of x for which this is greater or equal to 0. Remember that this is our y. X squared minus 4x minus 5 is our y. So we are to find the values of x for which our y is positive or equal to 0. The values of the values of x for which our y, this is our y, is greater or equal to 0. Remember, our y here is 0. Our y there is 0. So we are looking for the values of x for which this is positive, for which our y is positive. So obvious, when we look here, our y will be positive only above the x-axis. Below the x-axis, it's negative. In other words, when you go that direction, our y is positive. When you go for the values of x, we are talking about the values of x. When you go that direction, our y is positive. Right, let's go down just below the x-axis, right? Just below the x-axis, here, let's look, our y is negative. Our y is negative here. So for our y to be positive, it has to be this or less, this or greater. Therefore, it's where x is less or equal to, where x is less. When you go to that direction, it's where x is less or equal to negative 1. Or where x, when you go to that direction, our y is positive, it's above that. So it's where x is greater or equal to, the value there is 5. Right, let's continue.
Without any further calculations, sketch the graph of let x equals negative x squared plus 4x plus 5.
Right, the next question, without any further calculation.
Sketch the graph of let x equals negative x squared plus 4x plus 5.
We are to sketch this graph. So when you look at this graph, it's x minus x squared plus 4x plus 5. Without any further calculations, sketch this graph. What happened when you look at the two functions? Looking at the two functions, g at x is formed by saying this. When you look there, g at x is formed by multiplying f at x by negative. In other words, if this is multiplied by negative, we are reflecting. That's a reflection. We are reflecting, remember, y is affected. We've made an example. Let's say x1, x2, like that. And our y is positive. So if you are to reflect on that line, we are going to have this. This is still x1, x2. But then the thing that have happened, if this is x like that, our y will be negative. In other words, we are reflecting the graph of f about the x-axis. If we are reflecting about the x-axis, y will be affected, but x won't be affected. Only y will be affected. Let's sketch this graph. In other words, we are reflecting this graph about the x-axis to form the graph of G. Let's draw a Cartesian plane again. Write the graph of f here. It's concave up, but after reflection, it will be concave down. It will be concave down. Remember, the x values doesn't change, which means the x and y, our x-intercept won't change. The only thing that will be changing here are the values of y. When you are to reflect about the x-axis, we multiply our y by negative. So, when you look here, our turning point, 2 is to negative 9. After reflection, this will be 2 is to 9. This is the reflection. Reflection